Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, there are 3 ore cars, each with a mass of 1,000 kilograms, that are being held in a rail in a mine at an angle of theta, which happens to be 30 degrees. And the cable between the last 2 cars here stretches to 15 centimeters before it breaks, and the third car goes rolling down the incline. We're being asked to figure out assuming that the cable obeys Hooke's laws, what the frequency is going to be, and then the amplitude of the oscillations resulting in the 2 cars that remain hooked together after the third car breaks off. So first thing we're going to do is we're going to find omega here, and omega is going to be, omega x is going to be the magnitude of the force, that is the gravitational force, acting on each of the ore cars along the incline. So we can use the equation mass times gravity times sine of theta. So our omega x is going to be 1,000 times 9.8 sine 30. And when we do that, we find that our omega x is going to equal 4.9 times 10 to the 4th newtons. Now, as it said, we're assuming that this will obey Hooke's law, and based upon that, we can write that since there are 3 cars, we can have 3 omega x is equal to kx, where x is the distance that the cable car stretches, and we can solve for k. So we find that k equals 3 omega x divided by x, and when we substitute in our values here, we have 3 times 4.9 times 10 to the 4th newtons divided by 0.15 meters. So that tells us that our k is 9.8 times 10 to the 5th newtons per meter. So now to go and find our frequency, we are going to use the equation frequency equals omega over 2 pi. And then we can substitute in for omega, we can have the square root of k over 2m divided by 2 pi. When we substitute in for our omega. And when we go ahead and plug in the numbers that we have our k right here. We'll have our frequency equals the square root of 9.8 times 10 to the 5th newtons divided by 2 times 1,000. Again, there are 2 ore cars remaining, and have that all divided by 2 pi. And we get that our final frequency is going to be 1.11 hertz. Alright, now to find the amplitude, we have to take into consideration that we have to think about the equilibrium in both positions, when there was the third car attached and then when there were only the 2 cars attached. So our initial displacement is going to be 3 times our omega x divided by k, whereas our displacement after is going to be 2 omega x divided by k. And we need to find the difference between the two. So our delta x is going to be 3 omega x minus 2 omega x, all divided by k, which simplifies to simply omega x divided by k. And plugging in what we have for our omega x, which we calculated over here as our 4.9 times 10 to the fourth, we have that our delta x is 4.9 times 10 to the fourth newtons, divided by our k, which again is over here, which was 9.8 times 10 to the fifth Newton meters, making our final amplitude equal to 0.05 meters.